Hey guys, today let's solve some KCL problems. Kirchhoff current law states that total current entering a node is equal to total current leaving that node. Let's observe this junction A. Here I1, I2, I5 are entering the junction. Let's write their algebraic sum. Now this will be equal to total current leaving the junction. In this case, it will be I3 and I4. Let's use this concept in the upcoming question. Here, we need to find the value of I1, I2 and I3. Let's observe the direction of current in junction A. We can see that all of them are leaving the junction, and no current is entering here. So let's write the sum of currents leaving the junction. And this will be equal to 0 as no current is entering here. From here we get I1 equals 5 amps. Let's look at junction B. Here, minus 6 ampere is the only current entering the junction, and I2 and 2 ampere are leaving the junction. So we can write minus 6 equals I2 plus 2. So we get I2 equals to minus 8. Let's observe C. Here 2 ampere is entering and I3 and minus 2 ampere are leaving. So I can write 2 is equal to minus 2 plus I3, and I3 is equal to 4 ampere. Pretty easy, right? Let's do a similar problem. It low-key looks like a rice ball. Anyway, we need to find I1 and I2 here. Now let's apply KCL at junction B. We get I1 equals minus 8 minus 6. So I1 equals minus 14 ampere. Let's do the same for C. Applying KCL, we get I2 minus 6 equals to 4. Therefore, I2 equals 10 ampere. Let's move on to next question. This question asks to find the value of V0 and power supplied or absorbed by this dependent source. Let's begin by identifying the nodes to make our life easier. Let's identify the currents entering or exiting node A. Since current flows from positive to negative terminal, the direction of I3 will be towards node A. Now, applying KCL at node A, we get I1 plus I2 plus I3 equals 0. Put the values of I1 and I2. For I3, we can simply apply Ohm's law, which is I equals to V by R. Multiply both sides by 10 to make the equation easier. From here, we get V0 equals to minus 11.9. Before moving to next step, let's review passive sign convention. If current enters the voltage or current source from positive terminal, the source will absorb power, and its magnitude will be positive. And if current enters the voltage or current source from negative terminal, then the source will supply power, and its magnitude will be negative. Let's apply this concept to find the power. Because of this negative sign, A node will be negative terminal, and B will be positive terminal. Now pause the video and try to identify if the power will be negative or positive. Since current is entering the source from positive terminal, power will be positive and it will absorb power. Let's determine the value of I, which is basically the current in this branch. We can write I equals I2 equals 2V0. Putting the values, we get I equals to negative 23.8 amps. Let's find V. Potential difference between these three branches will be same. So we will find potential difference between these 2 points. We know V equals to IR. Since current flowing in this branch is I3, we can replace I with I3, and resistance will add up as they are in series connection. To find I3, we can simply apply KCL at node A. So we get I3 equals minus 1.2 ampere. Plug in the values and you will get V equals to negative 24. Now let's put the values of V and I. Multiplying these, I get 571.2 watt. Since the calculated value is also positive, it means that the source will absorb power. If it were negative, then it would mean that the source will supply power. In this problem, we need to find I naught and V naught. Let's start by identifying the nodes. Let's indicate the directions. We know current flows from positive to negative terminal, so this current will exit node A. Let's apply KCL at node A. 15 minus I naught minus V naught by 12 equals to 0. Multiply both sides by 12 to make your life easier. Let's name this equation 1. Now look at this branch. We will find voltage difference of this branch, which is simply V naught. Using Ohm's law, we can write V naught equals I naught into 2. Let's name this equation 2. We will put the value of V naught in equation 1. So I naught equals 6.92 ampere. Let's plug the value of I naught in equation 2. So we get V naught equals to 13.846 volt.